Hi everybody. Today we shall discuss how to do fast Fourier transform using decimation in time. So there are two ways by which fast Fourier transform can be approached. One is DIT, that is decimation in time, and another one is DIF, decimation in frequency. So today we shall discuss about DIT algorithm. So before entering into the video, kindly subscribe our channel Knowledge Academy. Now let us enter into the video. So here is the question. So this question was asked in an university examination, an university theory examination in communication, in digital signal processing paper for CSE students. So here it is asked to compute 8-point fast Fourier transform using radix 2 DIT algorithm, and the sequence is given. X of n is equal to 2, 2, 2, 2, 1, 1, 1, 1. So we have discussed already about this video in Tamil language available in our channel. Now the same thing is going to be discussed. We are going to discuss the same thing in English. So here this is the question x of n. The sequence is given and it is given as a radix 2. So radix 2 means we have to arrange the number of sequence in the power of 2. So here the number of sample points available in this sequence given in the question is 8. 8 sample points are given. So when we arrange, when we show this in the form of, in the power of 2, it becomes 2 power 3. And the 3 represents the number of stages that we have to do to converge at the final answer. So this is how it goes. So there will be 3 stages before getting the final FFT sequence. So here again it is given as decimation in time. So for proceeding the question with decimation in time, we must know what is the butterfly diagram for decimation in time and what are the procedures that we should follow to get the final answer. This is the butterfly diagram for decimation in time algorithm. So A is given. At any stage when we are able to draw butterfly diagram, so we have to consider A and B, and this Twiddle factor is also there. We have to multiply B compulsorily with this Twiddle factor, and in the upper part we have to add, and in the lower branch we have to subtract the multiplied B with Twiddle factor from A. Okay, so this is the butterfly diagram for a decimation in time. So whatever the case, we have to multiply this B with the Twiddle factor. So this B should be multiplied with this Twiddle factor in whatever the case, and in the upper part we have to add that one with A, and in the lower branch we have to subtract that one from A. So this is the procedure that we have to follow in decimation in time algorithm. Okay, and here is the explanation for Twiddle factor. The Twiddle factor is given as Wn power k. Here is the expansion of Wn. Wn is equal to e power minus j 2 pi by n. Wn is equal to e power minus j 2 pi by n. So Wn power k is e power minus j 2 pi k divided by n. And here we are going to use 4 Twiddle factors. We are going to substitute 4 values for k. They are W8 power 0, k equal to 0, k equal to 1, k equal to 2, and k equal to 3. Since it is an 8-point DFT, 8-point FFT, 8 divided by 2 is 4. So we have to use 4 values for k starting from 0. So those 4 values are k equal to 0, k equal to 1, k equal to 2, and k equal to 3. When we substitute these values in Twiddle factor, it becomes W8 power 0, W8 power 1, W8 power 2, W8 power 3. So before proceeding with the question, we have to find the values for these Twiddle factors. W8 power 0, when we substitute in this formula, it becomes e power minus j 2 pi 0 by 8, that is equal to 1, right? And w8 power 1, when we substitute in the formula, it becomes e power minus j 2 pi by 8, it is equal to e power minus j pi by 4. And when we expand this in trigonometric version, cos pi by 4 minus j sin pi by 4, cos pi by 4 or j sin pi by 4, the values are same. And when we substitute, it becomes 1 by root 2 minus j 1 by root 2. When we expand this, again the value of 1 by root 2 is 0.707. So it becomes 0.707 minus j into 0.707, right? Similarly, we have to substitute the values for w8 power 2. We have to find the values for w8 power 2, that is minus j, and w8 power 3, that is minus 0.707 minus j 0.707. So this is how we find the values for Twiddle factor. Now we are going to use these values in finding the fast Fourier transform using decimation in time, which will be discussed in the next slide. Okay. Now, to proceed with decimation in time, we have to arrange the sequence in bit reversal order. So the explanation proceeds here. So here are the samples: 2 2 2 2, 1 1 1 1. So 0th element is 2, first element is 2, second element is 2, third element is 2, fourth element is 1, fifth element is 1, sixth element is 1, and seventh element is 1. So here we are focusing on the place value. We are focusing on the position of these sample points. Now we are going to convert these position values into binary values. For example, here the maximum position, the value for the maximum position is 7. When we convert this 7 into binary, it becomes 1 1 1. So totally 3 digits are there. So when we convert all these position values into binary, we have to write them in 3 digits. For example, the binary equivalent of the position value 0 is 0. And instead of writing it as a single 0, it is appreciable to write it as 0 0 0. And the binary equivalent of number 1 is 1. The first position, number 1 is 1. And instead of writing it as 1, it is good to write it as 0 0 1. The value is not going to get changed, but it will be very helpful to arrange it in bit reversal order. And the next one, number 2, the binary equivalent is 1 0, and it should be written as 0 1 0. So like that, we have to convert all the position values into binary equivalent. So this is what I have done here. So I have converted the place value into binary equivalent here. So 0 is written as 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, and 1 1 1. So I have written like this. And in this column, I have written the bit reversal order. So what I have done? So I have written I have written 0 0 0 in this direction. While writing the bit reversal order in the next column, I have written the same number in this direction from right to left. So 0 0 0 is written from in this direction from right to left as 0 0 0. And the next number 0 0 1, when I write this one from right to left, again I have written 0 0 1, and the number becomes 1 0 0. When I read, it becomes 1 0 0. And the next number 0 1 0, when I write it in bit reversal order, it is again 0 1 0. This 0 1 1, when I write from right to left, it becomes 0 1 1. and when I read it, it becomes 110, right? So like that we have to do for all the position values, and once again we have to convert this bit reversed position value into decimal equivalent. So when I convert this one into decimal equivalent, I have got the order like this: 0th first, then next comes 4th position, next comes 2nd position, next comes 6th position, next comes 1st position, next 5th position, next 3rd position, and then 7th position. So this is how I arrive at the position values, bit reversed position values of the 8 sample points. Right now I have to write the corresponding numbers here. In 0th position I have got 2, I have written here. In 4th position I have got 1, so I have written here. In 2nd position I have got 2. In 6th position I have got 1. In 1st I have got 2. In 5th 1. In 3rd 2. In 7th position 1. So I have written them like this. Right? Now we are entering into the main part, that is the butterfly diagram. So here there are 4 butterflies available in this stage. So this is stage 1. So as I mentioned already, since this is radix 2, when we write the total number of sample points in the power of 2, it becomes 2 power 3 equal to 8. So we have got 3 stages. We have to proceed the problem in 3 stages, and this is the first stage. In this first stage there are 4 butterflies. In all the stages there will be 4 butterflies, but the position of A and B for each butterfly, we have to be very careful on that. In the first stage we are going to draw the butterfly for immediate lines, for immediate next lines, right? So here this is one butterfly, this is one butterfly, this is one butterfly, and one more butterfly. This is the last butterfly. So there are 4 butterflies available, right? And in the first butterfly, in DIT, as I mentioned already, whatever the case, we have to compulsorily multiply the value B with the twiddle factor. For stage 1, only one twiddle factor we are going to use, that is W8 power 0, and the corresponding value is 1. The value of W8 power 0 is 1. So we have to multiply B with 1. So here in the first butterfly, B is 1. When I multiply the B with 1, 1 into 1 is 1. So I have taken the multiplied B here, that is B into Wn power k is given here, and this is A, right? The upper part of the butterfly is got after adding A and multiplied B with the twiddle factor. So I have got 2 plus 1 as 3, and in the lower branch it is subtraction. So 2 minus 1, that is 1. Similarly, for the next butterfly, I am multiplying B with the twiddle factor, and I have got the same value. Since the value of twiddle factor is 1 in this stage, whatever the value of B comes, when we multiply that with 1, the same value is taken for addition and subtraction in the butterfly. So again, in the upper part I have added, so 2 plus 1 is 3, and in the lower part I have subtracted, so it is 2 minus 1, that is equal to 1. Again, in the third butterfly, when the value B is multiplied with the twiddle factor, it is again coming as 1, and in the upper part 2 plus 3 is 1, in the lower part 2 minus 1 is 1. Again, in the fourth butterfly the same thing happens, right? Okay. So this is stage 1. Now I am going to proceed with stage 2. In stage 2, again there are 4 butterflies. This is butterfly 1. The first butterfly is drawn between first line and third line. Second butterfly is drawn between second line and fourth line. Third butterfly is between fifth line and seventh line. Last butterfly, fourth butterfly, is between sixth line and eighth line. So we have taken alternate lines to draw butterflies, right? Okay. So here, this is the first butterfly, and this is B for the first butterfly. This is A for the first butterfly. There is no change in A, so I have taken this A here. Whereas for B, I have to multiply this with twiddle factor. Here in this stage 2, we are going to use 2 twiddle factors. One is W8 power 0, another one is W8 power 2. We already know the value of W8 power 0 as 1 and W8 power 2 as minus j. So with the first butterfly, I am going to use the twiddle factor W8 power 0, that is equal to 1. And when I multiply that twiddle factor with B, I am getting the same value. So I am taking that multiplied twiddle factor multiplied with B to the next stage. So I am getting the same value as 3. Now in the upper part, I am getting the answer, getting the result by adding this A and the twiddle factor multiplied with B. So 3 plus 3 is 6. So here I have got 6. Now in the lower part, I have to do subtraction. So 3 minus 3 is 0. So first butterfly is over. Now this is second butterfly. This is the B for second butterfly. I have to multiply with the twiddle factor W8 power 2, that is equal to minus j. And I am getting the result as 1 into minus j as minus j. I am taking it here, right? So I am getting minus j here. And the A for this butterfly is 1. So it is taken here directly. And in this butterfly, the upper part I am getting by adding these two things, this one and this one. So it is 1 minus j, and in the lower branch I am getting by subtracting this 1 and minus j. So the answer is 1 plus j. 1 minus of minus j becomes 1 plus j, right? So the same thing I am proceeding with the third butterfly. So this is the third butterfly. For the third butterfly, again the twiddle factor to be multiplied is W8 power 0 equal to 1. So 1 into B, B is 3 here. So 1 into 3 is 3, and A is 3. So I am not making any change to A. I am taking A directly. So that is 3. In the upper part, again I am I am adding 3 plus 3, that is equal to 6. In the lower part, I am subtracting 3 minus 3 is 0. Now in the fourth butterfly, this is the fourth butterfly. This A is taken. There is no change to A. So I am taking this A directly. And for B, this is B. B is multiplied with the twiddle factor minus j. So 1 into minus j is minus j. And in the upper part, I am adding 1 minus j is 1 minus j. And in the lower part, I am subtracting 1 minus of minus j is 1 plus j. So this is how I am doing with the butterflies of the second stage. Now we shall proceed to the third stage. In the third stage, again there are 4 butterflies. we are drawing the butterfly diagram between the lines first line and fifth line, one butterfly, first line and fifth line. Second butterfly is between second line and sixth line. Third butterfly is between third line and seventh line. Fourth butterfly is between fourth line and eighth line. So this is how we have to draw butterfly diagram for the last stage. So this is the stage 3. This is stage 3. We have to proceed in the similar way as we did in the previous stages, but the only difference here is here 4 twiddle factors will be involved. For the first butterfly, the twiddle factor involved is W8 power 0. For the first butterfly, the twiddle factor involved is W8 power 0. In the second butterfly, the twiddle factor involved is W8 power 1. The third butterfly, W8 power 2. And then the fourth butterfly, W8 power 3. And we have to proceed in the same way. We have to multiply B with these twiddle factors, and in the upper branch we have to add to get the result, and in the lower branch we have to subtract from A to get the final result. And this is the result that we have got. This is the result we have got after doing all the mathematical calculations. 12 1 minus 2.414j, 0 1 minus 0.414j, 0 1 plus 0.414j, 0 1 plus 2.414. So this is the final result that we have got. Now we have to arrange this sequence in order. And this is the final answer, x of k. So this is the final answer, FFT using DIT. 12 1 minus 2.414j, 0 1 minus 0.414j, 0 1 plus 0.414j, 0 1 plus 2.414j. So this is the final answer. This is how we find FFT using DIT, radix to DIT. The same example is available in Tamil language also. So kindly watch, and it may be beneficial to you. In the next video, we shall see how to do decimation in frequency, how to solve a fast Fourier transform using decimation in frequency with the same example. If you like the video, kindly share, comment, like, and subscribe the channel. Thank you for watching. Meet you again in the next video. Bye.